I'm Dr.B.Krishnaveni, working as an assistant professor in Department of Mathematics, Aditya University. Today we are going to discuss about Taylor series of a function in two variables. So in general, we call this as a Taylor series, and from this we can extract the series called Maclaurin series also. So at the end of this lecture, student will be able to find a Taylor series of a function in two variables. So now let's see what is Taylor series of a function in two variables. Taylor series expansion of function fxy at a comma b, or in the neighborhood of a comma b, or in powers of x minus a and y minus b, is given by fxy is equal to f of a comma b plus 1 by 1 factorial into x minus a fx of a comma b plus y minus b into fi of a comma b plus 1 by 2 factorial into x minus a whole square fxx of a comma b plus 2 into x minus a into y minus b into fxy of a comma b plus y minus b whole square fyy of a comma b plus the third term is given by 1 by 3 factorial into x minus a whole cube f x x x of a comma b plus 3 into x minus a whole square into y minus b into f x x y of a comma b plus 3 into x minus a into y minus b whole square fx y y of a comma b plus y minus b whole cube f triple y of a comma b. So this gives the Taylor series expansion of the given function, which is in two variables, that is fxy in an interval a comma b, or we can say that in the neighborhood of a comma b, or else in the powers of x minus a and y minus b. So now if you see the series, you are getting the terms like fx, fy, fxx, fxy, fyy, similarly fxx, fxxy, fxyy, fyy. So all this are representing partial derivatives. The first two are first order partial derivatives, next three are second order partial derivatives, the remaining are representing third order partial derivatives. So now we'll discuss the same by taking the question here. Given the question is expand e power x cos phi near the interval 1 comma pi by 4 by Taylor series. So let's take the given function as f of x comma y is equal to e power x cos y, and the interval given, that is a comma b, as 1 comma pi by 4. So which means here we need to take a is equal to 1, b is equal to pi by 4. Now write the Taylor series by taking a is equal to 1 and b is equal to pi by 4. Then what Taylor series of f of x y in two variables is? F of x comma y is equal to f of a comma b means f of 1 comma pi by 4 plus 1 by factorial x minus 1 into fx of a comma b 1 comma pi by 4 plus y minus b y minus pi by 4 fi of a comma b, that is 1 comma pi by 4 plus 1 by 2 factorial into x minus 1 whole square fxx of 1 comma pi by 4 plus 2 into x minus 1 into y minus pi by 4 fxy of 1 comma pi by 4 plus y minus pi by 4 whole square fyy of 1 comma pi by 4 plus so on. So here we wrote the Taylor series up to two terms, which includes first order partial derivatives and second order partial derivatives. And here the given question, we replace the series with a comma b, that is with 1 comma pi by 4. So now to expand this or to substitute in this, we need f of 1 comma pi by 4, fx of 1 comma pi by 4, fy of 1 comma pi by 4, so on, fyy of 1 comma pi by 4. So now in order to find out these values, we need already given what is fxy. Thereafter, we need to find out fx, fy, fxx, fxy, fyy at the given point, that is 1 comma pi by 4. So, now take our given function fxy is equal to e power x into cos y. So, here the series we represented with equation number 1 and given xy with equation number 2. Find out f of 1 comma pi by 4, that is substitute here x is equal to 1, y is equal to pi by 4. So, then f of 1 comma pi by 4 is equal to e power 1 into cos power pi by 4, which is equal to e into cos pi by 4 value is 1 by root 2, that is equal to e by root 2. So, now differentiate to 2 with respect to x, which gives fx. Fx means dou f by dou x is, that is dou by dou x of f is e power x cos y. So, here we are doing the partial derivative with respect to x, means y constant. So, hence in the function cos y remains as constant and e power x derivative is e power x into that is cos y. Let us take this as equation number 3. Now find out fx of 1 comma pi by 4. Substitute x is equal to 1, y is equal to pi by 4 in fx. So, that gives e power 1 into cos pi by 4, which is equal to e by root 2, because cos pi by 4 value is 1 by root 2. Next, find out the partial derivative of f with respect to y represented by fy, that is dou f by dou y. Now, x is constant, dou by dou y of e power xy, e power x constant and cos y derivative is minus sin y, which is equal to minus e power x sin y. Let us take this as equation number 4. Calculate fy of 1 comma pi by 4. Here substitute x1 minus e power 1 y pi by 4 sin pi by 4, that is equal to minus e into sin pi by 4 1 by root 2, that is minus e by root 2. So, got the values for the second term, that is fx of 1 comma pi by 4, fy of 1 comma pi by 4. So, next need to find out fxx of 1 comma pi by 4, fxy of 1 comma pi by 4 and fyy of 1 comma pi by 4. For that, let us calculate the second order partial derivatives. Fxx means dou square f by dou x. So, differentiating f with respect to x 2 times partially, that represented by dou square f by dou x square. So, which is nothing but dou by dou x of dou f by dou x. So, what dou f by dou x? That is fx is e power x cos y, already we calculated, substitute here. Now, find out the derivative with respect to x, that is e power x derivative is e power x, cos y is constant. Now, find out the value fxx of 1 comma pi by 4. So, which is equal to e power 1 into cos pi by 4, e cos pi by 4 is 1 by root 2. So, therefore, the answer is e by root 2. Now, to get fxy, which represented with dou square f by dou x dou y. So, that is dou by dou x of dou f by dou y, that is equal to dou by dou x of, what is the dou f by dou y is? Here we calculated minus e power x sin y. Now, do derivative with respect to x partially, means y constant, minus e power x, derivative is minus e power x, sin y constant. Find out the value fxy of 1 comma pi by 4. So, now substitute x is equal to 1 here, minus e power 1 into y sin pi by 4, y is equal to pi by 4, that is sin pi by 4. So, which is equal to minus e by root 2. Next, differentiating 4 with respect to y. Where is 4 is? This is 4. Now, we need dou square f by dou y square, that is fyy, that is dou square f by dou y square. Now, again differentiating this with respect to y, that is dou by dou y of minus e power x sin y it is, which is equal to, now x constant minus e power x is constant, sin y derivative is cos y. Find out fy of 1 comma pi by 4, which is equal to minus e power 1 into cos pi by 4. So, that is equal to minus e by root 2. Got the values of all, hence substitute in one, that is a Taylor series of two variables fxy. So that is e power x cos y is equal to f of 1 comma pi by 4, the value is e by root 2 plus 1 by 1 factorial x minus 1 into fx of 1 comma pi by 4 e by root 2 plus y minus pi by 4 into fy of 1 comma pi by 4, that is minus e by root 2 plus 1 by 2 factorial into x minus 1 whole square fxx of 1 comma pi by 4, substitute e by root 2 plus 2 into x minus 1 into y minus pi by 4 fxy of 1 comma pi by 4 minus e by root 2 plus y minus pi by 4 whole square into fyy of 1 comma pi by 4, which is minus e by root 2 plus so on. So which gives the Taylor series for the given function. So now let us discuss one more example in this, that is finding the Taylor series for the given function. And the question is, expand the function fxy is equal to tan inverse of xy in the powers of x minus 1 and y plus 1. So which means they are giving, or they are asking the question as, find the Taylor series expansion of fxy in powers of x plus a and y plus b. Sorry, x minus a and y minus b. So now given fxy is tan inverse xy. Compare x minus 1 with x minus a, y minus b with y plus 1. Then what a is equal to 1 and b is equal to minus 1. So now write down the Taylor series expansion in powers of x minus 1 and y plus 1. That is, the Taylor series is substitute a is equal to 1, b is equal to minus 1. So then the Taylor series becomes fxy is equal to f of a comma b, that is 1 comma minus 1 plus 1 by 1 factorial into x minus a into fx of a comma b plus y minus b into fi of a comma b on taking a b values, which gives x minus 1 into fx of 1 comma minus 1 plus y plus 1 into fi of 1 comma minus 1 plus 1 by 2 factorial into x minus 1 whole square fxx of 1 comma minus 1 plus 2 into x minus 1 into y plus 1 fxy of 1 comma minus 1 plus y plus 1 whole square into fyy of 1 comma minus 1 plus so on. Let it be equation number 1. So now again, this whole representing the Taylor series for the given function. Now need the values, what is f of 1 comma minus 1, fx of 1 comma minus 1, fy of 1 comma minus 1, like that. The second order values also fxx of 1 comma minus 1, fxy of 1 comma minus 1 and fyy of 1 comma minus 1. So hence consider the given function, that is tan inverse xy. First calculate f of 1 comma minus 1. So x1 y is equal to minus 1. Then what the value will be equal to? Tan inverse of 1 into minus 1, which is tan inverse minus 1. And we know that tan inverse of minus theta is minus tan inverse 1. And where we will get 1 for tan is at theta is equal to pi by 4. So therefore the answer is minus pi by 4. Next we need fx of 1 comma minus 1, means first need to find out fx of x comma y, that is fx. Fx means first order partial derivative with respect to x, which is dou f by dou x. That is equal to dou by dou x of tan inverse xy. So first what tan inverse derivatives? 1 by 1 plus x square, here it is xy whole square into inner derivative, that is dou by dou x of xy with respect to x partially here, which is equal to 1 by 1 plus x square y square and x derivative is 1 into y. So which is y by 1 plus x square plus y square, equation number 3. Now find out fx of 1 comma minus 1, taking x1 y is equal to minus 1 in this, y minus 1 divided by 1 plus 1 square minus 1 whole square, that is equal to minus 1 by 2. Next, differentiate the given function, that is 2 with respect to y, which is fy. Fy means dou f by dou y, partial derivative of f with respect to y, x constant now. Now again find out tan inverse xy with respect to y, that is dou by dou y of tan inverse xy. Here x constant, first tan inverse derivative is 1 by 1 plus xy whole square. Now inner derivative with respect to y, dou by dou y of xy. So which is 1 by 1 plus x square y square into x constant, y derivative is 1. So which is equal to x by 1 plus x square y square, equation number 4. Now find out fy of 1 comma minus 1. Substitute x is equal to 1 and y is equal to minus 1 in this. 1 by 1 plus 1 square minus 1 whole square, which is 1 by 2. Next, second order partial derivatives. Fxx means derivative of f with respect to x 2 times partially, that is dou square f by dou x square, which can be written as dou by dou x of dou f by dou x. What dou f by dou x value is y by 1 plus x square y square. Now do derivative with respect to x, y constant. So you are getting this is equal to, either you can apply u by v or you can apply directly y into here 1 by x form. Since y constant, 1 by x derivative is minus 1 by x square into the inner derivative, here it is. Now find out fx of 1 comma minus 1 by taking x is equal to 1, y is equal to minus 1, you got the value is equal to 1 by 2. Then find out fxy, that is f with respect to x then y, which is dou by dou x of dou f by dou y is calculated just now, that is x by 1 plus x square y square. With respect to x now, it is in the form of u by v derivative u dash v minus u v dash by v square, that is on simplification you got the function is this. And now find out fxy of 1 comma minus 1. Taking x is equal to 1, y is equal to minus 1, you got the value is equal to 0. Next, differentiate to 4. What 4 is? Fy with respect to y now, that is fyy. Fyy is nothing but dou square f by dou y square, which is equal to dou by dou y of dou f by dou x. So what dou f by dou y is? X by 1 plus x square y square. With respect to y, take it as in the form of u by v. U constant, here x is constant, derivative 0 into u minus u into v dash by v square. On simplification, you got this is equal to minus 2x cube y by 1 plus x square y square whole square. Now find out fyy of 1 comma minus 1 here. Taking x1, y is equal to minus 1, you got the value is equal to 1 by 2. Now substitute all the values in the Taylor series, which is given by tan inverse xy, that is f of xy is equal to, first value will be equal to minus pi by 4, that is f of 1 comma minus 1 plus 1 by 1 factorial into x minus 1 into fx of 1 comma minus 1, that is minus 1 by 2 plus y plus 1 into fy of 1 comma minus 1, 1 by 2 plus 1 by 2 factorial into x minus 1 whole square fxx of 1 comma minus 1, 1 by 2 plus 2 into x minus 1 into y plus 1 fxy of 1 comma minus 1 0 plus y plus 1 whole square fyy of 1 comma minus 1. What you got, that value is equal to, need to replace that with 1 by 2. Here you can write 1 by 2. So which can be written as tan inverse xy is equal to minus pi by 4 minus of x minus 1 by 2 plus y plus 1 by 2 plus x minus 1 whole square by 4 plus y plus 1 whole square by 4 plus so on, which gives the required Taylor series for the given function fxy, which is given by tan inverse xy. So this is all about Taylor series. Now next is Maclaurin series. What Maclaurin series is? It is also a Taylor series for which a comma b is equal to 0 comma 0. So that is in the Taylor series expansion, if you substitute a is equal to 0 and b is equal to 0, we will get a Maclaurin series. That means we call it as Maclaurin series expansion of fxy at 0, 0 or in the neighborhood of 0 comma 0 or in the powers of x and y, and is given by now the Taylor series only, but just by taking x is equal to 0 and y is equal to 0. Then what the series will be equal to? Fxy is equal to f of 0 comma 0 plus 1 by 1 factorial into x into fx of 0 comma 0 plus y into fy of 0 comma 0 plus 1 by 2 factorial into x square fxx of 0 comma 0 plus 2xy fxy of 0 comma 0 plus y square into fyy of 0 comma 0 plus 1 by 3 factorial into x cube fxx of 0 comma 0 plus 3x square y fxxy of 0 comma 0 plus 3xy square fxyy of 0 comma 0 plus y cube into fyy of 0 comma 0. This gives the Taylor series expansion in the interval 0, 0 or in the powers of x and y. Now, let us get this by discussing the question. Expand the function f of x comma y is equal to e power x log of 1 plus y in terms of x and y up to the terms of third degree. So, here the question given in specific that need to expand up to third degree. Third degree means need to include the third term also. So, hence for this we need all these values, that is f of 0 comma 0, fx of 0 comma 0, similarly second orders as well as third order values at 0 comma 0. And we know that what Maclaurin series is, up to third degree we wrote here, that is f of x comma y is equal to f of 0 comma 0, 1 by 1 factorial fx 0 0 plus y into fy 0 0 plus 1 by 2 factorial into x square fxx 0 0 plus 2xy fxy of 0 comma 0 plus y square into fyy of 0 comma 0 plus 1 by 3 factorial into x cube fxxx of 0 comma 0 plus 3x square y fxxy of 0 comma 0 plus 3xy square fxyy of 0 comma 0 plus y cube into fyy of 0 comma 0 plus so on. Equation number 1. Now, let us find out the function values all at 0 comma 0. Given fxy is e power x into log of 1 plus y, equation number 2. And what value at 0 0 is, that is f 0 0. Put x 0, e power 0, y also 0, that is log of 1 plus 0. E power 0 1, but what log 1 value is 0, 0 into something is 0. Now, differentiate partially the equation number 2 with respect to x, that is fx, which is equal to dou f by dou x, which is equal to dou by dou x of e power x into log 1 plus y. Now, with respect to x, e power x derivative is e power x, log of 1 plus y is constant. Let it be equation number 3. Find out fx 0 comma 0. Put x 0 here, e power 0, and y 0 means log of 1 plus 0 it is. Again we are getting log 1 into 1, log 1 0, 0 is 0. Next fy we need, so hence differentiate 2 with respect to y partially, that is fy dou f by dou y, which is equal to dou by dou y of e power x log of 1 plus y. Now e power x constant, log derivative is 1 by 1 plus y. Find out the value at 0 0, fy of 0 0 is equal to e power 0 by 1 plus 0. E power 0 1 into 1, which is equal to 1. Next, second order partial derivatives. Differentiating 3, that is fx with respect to x gives fxx, which is dou square f by dou x square. That is equal to dou by dou x of dou f by dou x What is dou f by dou x is e power x log of 1 plus y. Now again with respect to x, e power x derivative is e power x, log 1 plus y is constant. Let it be equation number 1. Find out fx6 of 0 comma 0 here, which is equal to e power 0 log of 1 plus 0, that is equal to 0. Since log 1 0, 0 into something is 0. Next to find fxy, now differentiating 4 with respect to x or differentiating 3 with respect to y. Anything you can find out. Fxy, that is dou square f by dou x dou y, dou by dou x of e power x by 1 by 1 plus y. Now with respect to x, e power x derivative e power x, 1 by 1 plus y is constant, let it be equation number 1. Find out fxy of 0 0, that is e power 0 by 1 plus 0, that is equal to 1. Now differentiate 4 with respect to y, that is fy with respect to y is fyy, which is dou square f by dou y square, that is equal to dou by dou y of dou f by dou y. What is dou f by dou y is e power x into 1 by 1 plus y. Now with respect to y it is e power x into 1 by 1 plus y derivatives minus 1 by 1 plus y whole square. Since we know that 1 by x derivatives minus 1 by x square, here we got the function 1 plus. The inner derivative of 1 plus y is 1 only. Hence, the value is equal to minus e power x into 1 plus y whole square. Let it be equation number 1. Find out fyy of 0 0 here, which is equal to minus e power 0 by 1 plus 0 whole square, taking x 0 and y 0, which is minus 1 by 1, which is minus 1. Now let us start the third order partial derivatives. Now phi equation fxx. Now again differentiating with respect to x results fxxx, which is dou cube f by dou x cube. That is dou by dou x of dou square f by dou x square. What dou square f by dou x square is e power x into log of 1 plus y. Now again differentiating with respect to x, e power x derivative is e power x, log of 1 plus y is constant. Now what the value at 0 0 is e power 0 into log of 1 plus 0. Since log 1 0, 0 into something is 0. Next partial derivative in third order is fxxy, which is dou cube f by dou x square dou y, which gives dou by dou x of dou f by dou x, that is dou square f by dou x dou y, e power x into 1 by 1 plus y. Now with respect to x is e power x derivative is e power x, 1 by 1 plus y is constant. Find the value at 0 0. Taking x 0 and y 0, you got e power 0 plus 1 by 1 plus 0, which is equal to 1. Next to find out fyy, that for differentiating 7 with respect to y, that is fyy with respect to y, dou cube f by dou y cube it is, that is dou by dou y of, what is dou f by dou x square is minus e power x by 1 plus y whole square. Now integrating with respect to y here, minus e power x and 1 by 1 plus y square written as 1 plus y whole power minus 2. And what the derivative with respect to y is minus 2 into 1 plus y whole power minus 2 plus 1, which is minus 3, and can be written as minus 2 by 1 plus y whole cube. So minus into minus plus, therefore this is equal to 2 e power x by 1 plus y whole cube. Now the value at 0 0, take x 0 y 0, that is 2 e power 0 by 1 plus 0 whole cube, 2 by 1, which is 2. Now do substitution in this series, that is Maclaurin series. Fxy given as e power x log of 1 plus y is equal to f of 0 0, which is 0, 1 by 1 factorial into x into fx 0 0 0 plus y into fi 0 0 1 plus 1 by 2 factorial into x square fxx of 0 0. So what fxx 0 0 is? 0 it is. Next f2xy into fy xy 0 0 1 it is, plus y square fyy of 0 0 minus 1 plus 1 by 3 factorial into x cube into fxx of 0 0 0 it is, plus 3x square y fxxy1 plus 3xy square fxyy1 plus y cube into fyy of 0, 0, which is 2. On simplification, you got the series as e power x log of 1 plus y is equal to y plus first term. From the first term, you are getting y plus xy, 1 by 2 factor into 2xy, 2 to cancel, which is xy, minus y square by 2 plus x square y by 2 plus xy square by 2 plus y cube by 3. Now this series gives the Maclaurin series for the given function e power x log of 1 plus y. So here it is. Hence, this is the lecture for today, that is Taylor series of the function in two variables, and we are taking an interval as AB. If you substitute A0, B0 in this results into Maclaurin series. Hence, discussed both Taylor series and Maclaurin series of a function in two variables. Thank you.